This is part 8 in this YouTube series where I am working to convert this RPG game into this pseudo 3D racing game. In the last episode, I added some flair and polish to the title screen and game over screen. The focus of this episode will be removing the RPG elements and drawing the sky and the ground. We will also draw the road for the racing game, which will be drawn in a projected perspective, which is a technique used to create the illusion of depth in 2D graphics. Up until now in this series, the game has been a top-down RPG, but now we are going to transition to a pseudo 3D racing game. To do this, I need to remove the existing RPG elements from the game, such as the player character, enemies, and items. Most of this code is in the game scenes update and draw methods. Once that is cleaned up, the game should just show a blank screen, which it does. The pause screen and game over screens also still work as expected. This gives us a blank slate to work with. I first want to move the draw method to its own file, which will help keep the code organized and easier to follow in this video. I will need two methods, one to draw the ground and one to draw the sky. I will start with the ground first since it is slightly less complicated than the sky. I first define the horizon line, which is the point where the sky meets the ground. This will just be half of the screen height for now. The ground could be drawn using sprites, but I want to use Ebitengine's Draw Triangles method to create a more dynamic look. I will also use Draw Triangles for the sky and the road, so it will be easier to keep the code consistent. To use Draw Triangles, I need to define the vertices of the triangles that make up the ground. These are just points in 2D space. I am drawing the ground as a rectangle, so I need 4 points: the top left, top right, bottom left, and bottom right. Each point has an X and Y coordinate and a color. I am using a dark green for the ground closer to the horizon, and a lighter green for the ground closer to the bottom of the screen. This will give a nice gradient effect and help simulate depth. Next, I need to define 6 vertices, 3 for each triangle, chosen from the 4 points I just defined. So in my indices slice I will define the first triangle using the first 3 vertices, 0, 1, and 2, and the second triangle using the first, third, and fourth vertices. This will make a bit more sense in a moment after I explain how Draw Triangles works. Then, I need some draw options, and I can call the Draw Triangles method. It also needs an Ebitengine image, and this technique uses a 1x1 pixel image, which will be tinted with the color defined in the vertex. If I run the game now, I can see the ground being drawn on the bottom half of the screen. As I mentioned, each index correlates to an element in the vertices slice. So even though I have only 4 points, I can reuse them to create 2 triangles by defining the indices for each triangle. To illustrate this, the first triangle will use these vertices, and the second triangle will use these vertices. I can better explain this by visually drawing each triangle on the screen in the game. To do that, I will temporarily override the indices slice and create a new slice with example indices for each triangle and draw them in a different color. For the first triangle, I will use the first, second, and fourth vertices and draw it in blue. When I run the game now, I can see the first triangle drawn in blue. This is how Draw Triangles works. It takes the vertices and draws triangles based on the indices. Now, I will do the same for the second triangle, drawing it in orange. When I run the game now, I can see the second triangle drawn in orange. So when Draw Triangles is called, it connects the 2 triangles together to form a rectangle. Since the colors are both green, it looks like a solid rectangle with a gradient effect. I will leave this code commented out in case you want to visualize the triangles in your own game or experiment with it. Next, I need to draw the sky. I am using 3 colors here to give an even more advanced look to the sky, so it resembles a sunset. I am using a dark purple and 2 shades of orange. I defined some variables for these colors, so I can easily adjust them later and ensure the right color is in the right position. Just like the Draw Ground method, I create a slice of vertices. In this method, I format it slightly differently so it is a bit easier to read. Either format is fine, but I prefer this one since it is easier to read and maintain. I define my indices again, and then call Draw Triangles to render the sky. Now, the game has a ground and a sky, so it is starting to look like an in-game world. If I temporarily disable the ground, you will see I am actually drawing the sky to fill the entire screen. This is not necessary, but it can be useful later, if we move the horizon line up and down and still want to see more of the sky. The last element to add is the road. This also happens to be the most complex part of the game, because of the pseudo 3D mechanics. There are many resources online that explain this theory in detail, and I will be showing you one approach to implementing it. In order to actually draw the road, I need to project the 3D, in-world coordinates into 2D screen space. This requires the use of a perspective projection formula, which needs several parameters to work correctly. Two important elements we will need will be a player or camera object to represent the player's position and orientation in the world, and a road object that will hold the road segments. I want each of these to be an in-game entity with some shared characteristics. The RPG project this game is forked from already has an entity package, but I want to modify it slightly. It uses the sprite type to represent the entity, but I want this to be called entity instead. It already has an X and Y position, but since I am doing pseudo 3D, I also need a third Z coordinate. I can keep these delta values and the image field. With that done, I just need to rename any existing sprite references to entity. Now, in my new game scene constructor method, I add a player and a road. The road will be a slice of road segments, which are just a collection of entities in 3D space. To create that, I will make a new function to create the road segments. I am going to make a new game scene road.go file to separate the road logic into its own file. This function will accept a quantity of segments, which will be the number of road segments to create. For simplicity, I am making this 1000 units long, which will equate to 1 kilometer in the in-game world, and the function will return a slice of entities. I will be using the ler method I made in a previous episode to create the segments. I define a start and end Z coordinate, which means we will place segments within this range. So, for the given quantity of segments, t will be the factor to interpolate between the start and end points, and goes from 0 to quantity -1. Base z is then a linear interpolation, so we can use the lerp function here. After I add a safety clamping mechanism, I can create the road segments. This will be a straight road to begin with, so the x position will be 0, or centered. The y position will be the height of the road, which I will set to 0, meaning a flat road with no elevation. The z coordinate is how far into the world the segment is. Imagine the z-plane as the road stretching out in front of the player, with the player at the origin. Each time z increases, that road segment is further away from the player. The image field is set to a 1 by 1 pixel image, which will be tinted in a manner similar to the sky and ground. Lastly, the segment is appended to the road slice and returned. As of now, these z coordinates do not have depth in the game yet. If I try to draw them, they will simply be drawn in a straight line down the y-axis. If this was a top-down racing game, this would be fine, but I want to draw the road in a pseudo 3D manner. This means the segments that are farther away from the player should be smaller, and the segments that are closer should be larger. This is the essence of the perspective projection. Now, we need a function to convert the 3D coordinates of the road segments into 2D screen space. I will call this method projectPoint. It will accept an in-world x, y, and z coordinate. It will also accept a farthest z parameter, which will be the maximum z coordinate that will be visible on the screen. The function will return a 2D screen x and y coordinate, along with the scale factor. We first need to calculate the effective z coordinate, which is the difference between the farthest z and the current z coordinate. As you move forward down the road, world z increases, and in turn, effective z increases, making the projected scale smaller. This formula needs to know where the player is, so this function should actually be a method of the scene, so it can access the player entity. If the player is at world z, then the point is at the camera, so we clamp to 0.1 to avoid division by 0 errors. Secondly, we need to calculate the scale factor, which is the camera depth divided by the effective z. This means that objects nearer to the player will be larger, and objects farther away will be smaller. I need to define this camera depth, which I set to 4.8 times 1. The camera depth is essentially the focal length. By changing this value, I can change how zoomed in the road appears. If this value is smaller, the view will appear zoomed in, and if it is larger, the view will appear zoomed out. By multiplying by 1, I am setting this value to be freely scaled later, so I could replace 1.0 with a scale variable. Third, we need to calculate the minimum scale, which is the camera depth divided by farthest z. This will be the scale at which a point exactly at farthest z should appear. It is used so that the horizon line always stays at the same y, independent of small shifts in the player's z position. Fourth, we need to calculate base y, which is the screen y-coordinate for a world y-coordinate of 0. As scale increases above the minimum scale, for example, when an object is closer than farthest z, that y-coordinate is pushed downwards. Horizon y will simply be the screen height divided by 2, which is the center of the screen. If the camera height changes, everything will shift up or down proportionally, so I will set the camera height to a value that works well for the game. Next, we need to adjust for the object's actual world y-coordinate, which is the vertical offset above the ground. If the world y-coordinate is 0, the object lies on the road or ground. If an object is above the ground, this formula will push it upward on the screen so screen y is a bit smaller. Lastly, we need to calculate the screen x-coordinate. A world x-coordinate of 0 is centered on the screen, so we can use the scale factor to adjust the screen x-coordinate. If the object's world x-coordinate is greater than 0, it pushed the screen x-coordinate to the right by world x minus camera x, multiplied by the scale factor. If you were to pan the camera left or right, you are subtracting from that offset. Wow, that is quite the method. It will be reusable for any entity in the game, which our player and road segments already are. I will be able to use it for other road objects like trees, rocks or signs, and they will be scaled and positioned correctly. Ignoring any hard-coded values I currently have, I can now draw the road segments in a pseudo 3D manner. If your brain hurts already from trying to figure out that project point method, this next one is also pretty heavy. It took me quite a while to figure everything out, and I did a lot of reading, and a lot of trial and error to get it working. I cannot say I fully understand every aspect, but sometimes the best way to learn is by trying to teach it to someone else. Let me know in the comments or corrections based on your own experience. The first thing this method needs to do is collect all of the road segments that are still in front of the camera. This is accomplished with some conditional checks on the z-coordinate of each segment. Next, the segments are sorted so the farthest segments are drawn first, and the closest segments are drawn last. For each sorted segment, check that nothing behind nor beyond sneaks through. Now, we can call the project point method to convert the 3D coordinates into 2D screen space. Scale top tells us how large the segment in world space appears at that depth. Since I set the segment length to be 1.0, this effectively projects the next meter down the road. SY bottom will be slightly closer to the horizon than SY top, so it will appear to slant upwards. Next, we calculate the left and right x coordinates, subtracting or adding from the screen center, SX top, or SX bottom, gives us the trapezoid's 4 corners. Finally, I create the vertices and the indices as we did for the sky and ground. Then, we draw them to screen with draw triangles. I am actually not using scale bottom in this video, so I am skipping that for now. The last thing I need to do is choose a color for the road segments. I skipped over this initially to keep the code focused more on the projection logic, but now I can add it. I will just use a dark and light gray color. When I run the game, you will see the road segments drawn in a pseudo 3D manner. You cannot yet travel down the road and the segments just look like blocky rectangles, but this is a good start. In the next episode, I need to do a little cleanup of some hard codes, break the scenes package into smaller sub-packages, and then make the road move towards the player.